Hello and welcome to a screencast on composition of functions. Composition of functions is a concept that allows us to take two functions that are compatible in a certain way and make a new third function out of them. Let's see how this works with a couple of examples.
So there are many processes that we use every day that consist of a number of simple steps that are done in sequence. For example, when I make eggs for breakfast, this is a two-step process. First, I have to break the eggs and stir them up. That's a change process if you think about it. I'm changing the eggs from an in-the-shell state to a mixed-up-in-the-bowl state. Then I have to take those stirred-up eggs and cook them in the frying pan. This is a change process too. I'm changing the eggs from a liquid form to a solid form by applying heat. For the most part, we think of this whole process as a single process called making eggs, but really it's a combination of two processes that are compatible in the sense that the second process, the cooking in the pan, begins where the first process, the stirring up, ends. And this is done in a particular order. That order matters, of course. It wouldn't be a good idea to drop the eggs into the pan before I get them out of the shell. Likewise, computer programs are also processes that usually involve multiple simple processes that are chained together in a certain order. For example, let's suppose I wanted to write a program that takes a student's student ID number and returns their initials. This would really involve two processes joined together and done in sequence. First, I'd have to write a process that changes an ID number into the student's name. That could be a program that goes out to the university database and looks up the person's ID number and returns their full name to me. Then I would have another process that picks up where the first process left off. I take the student's name and then convert the name into initials. In one sense, we think of this as one large process, but really it's broken down into two processes that are simple, that are compatible, again in the sense that the second process starts where the first one ends, and they're done in order. Now, mathematically, processes like these are modeled by functions, and so what we're seeing here is that it's quite common to take two functions that are compatible, again in the sense that one function starts where the other ends, and connect them together to make a more complex but more useful third function. That notion is the basic concept behind what we will call function composition. Here's our formal definition. Let A, B, and C be non-empty sets, and let there be two functions f from A to B and g from B to C. Note that the domain of G is the codomain of f, so G begins where f ends. Then the composition of f and g is denoted by g circle f, and it's the function that goes from A to C, defined by g circle f of x is equal to g of f of x for all x in A. Now, what does this mean? Well, this is just a formal way of defining this connecting of processes that we saw earlier with making eggs or converting an ID number to initials. We're taking two simple processes that are compatible in the sense that the second one, which we're calling G in the definition, begins where the first one, which we called F, ends. We ensure the compatibility of these two functions by making the codomain of f equal to the domain of g. And then we just do these processes in order, f first and then g. Notice that we include all five main ingredients that we need for a function here. We've specified the domain and codomain. We have defined the rule for the function. Given an x in the domain, we evaluate f at that point, and then we take the output from f and evaluate g there. Since both f and g are functions themselves, we know that every point in the domain will be evaluated, and we also know there will be no splitting.